Welcome back to math. Today, module 4, lesson 11. This is solve and create fraction word problems involving addition, subtraction, and multiplication. As you can see right here, I've got a problem. How could I do this? I could structure it in all kinds of ways. But this would be one way I could structure this. I could structure it like something times something up on top of my line and a 2 on the bottom, right? Well, we can take this 1 and put it over here. Take the 8, put it over here. What's 8 times 1? That would be 8, and the bottom number is 2. How did we get that? Well, by moving the 2 over, or it's like multiplying 2 times 1, because remember, 8 with a 1 under it is 8 wholes. If I have 9 with a 1 under it, it's 9 wholes. If I've got a 20 with a 1 under it, it's 20, right? Okay. Now the question becomes, can I make this into a whole number? Well, yeah, I think I could, because what goes on the inside of the house? That's right. You guys said the top number. Nice work. The bottom number goes on that. 2 times what is 8? Nice work. Someone said 4. I heard that. Good job. 2 times 4 is 8. We're going to subtract this out. We got 0. So our answer really is 4 wholes. Nice work. So now I'm going to have another one. Let's say I have a tape diagram and I have 8 plus 3. And I'm going to stack my tape diagram onto this. So the question becomes 8 plus 3 is what? 11. Well, what if I wanted to have this cut up into thirds? What would thirds be? If we put 3's in here, 3, 6, 9, and if we added another, this would be 12, right? But 12 is too much, isn't it? So we can't really use that. But if we use 3, that gives us 9, and we have a remainder of 2, right? So then how would we break this 2 up into thirds? Well, we could draw 2 pizzas like this, and then we could break the thirds up like that, right? How many of these thirds do you think I'm going to put in here? Well, let's say, just for the sake of that this is green, and we're going to make this the green box. So as you can see, I could put this green one in here, right? I could put this pink one in here and this orange one in here. Whoa, what about this other one? So my question is, how many thirds are we going to be putting? So how many green thirds do we have? This would be 1/3 and this would be 2/3, right? So we put 2/3. How many pink thirds are there? 2/3. And how many orange thirds are there? There are 2/3. So I hope that this helps you make sense of that. Looks like this. This one box is a half plus a fourth. Makes up this box. How do we figure what that would be? So what I'm doing here is I'm going to work the problem backward. So I'm going to start with saying, okay, I've got 3 boxes. That's why I have 3 here. And I have a half and a fourth over in this box. A half and a fourth in this box. So how do we do this? Can we turn one of these into the other? We can turn the 2 into a 4, can't we? That would be times 2, right? So if we times 2 times 2, that would be a 4. And if we times 2 times 1, that'd be a 2. Is 2/4 is 2/2 of 4? What would this equal? 2/4 plus 1/4. That would equal 3/4. Multiply it by 3. We're going to bring that down and this down. So I could put a 1 under the 3. 3 times 3 is 9. 4 times 1 is 4. What would go inside the house? The top number, good job. And the 4 would go on the outside. How many 4s are in 9? 4 times 2 is 8. And it leaves us with 1/4. So we have 2 and 1/4. So how would that look? How would I load these boxes? I'm loading the boxes up with a 3/4 here, and a 3/4 here, and a 3/4 here. And when we added them all together, we said we ended up with 2 and a 4th, right? So where does that go? That goes on the top where our question mark is. 2 and a 4th. We could have a word problem that says something like, we have 2 and a 4th fabric. We're going to cut it up into 3 equal sections. But then we're going to cut each section into a half and into a 4th to make our special fabric thing. All right, we have a new problem. It says Jim and Jane share 16 ounces of cereal. By the end of the week, Jim has eaten 3/8 of the box and Jane has eaten 1/4 of the box of cereal. What fraction of the box is left? What do we want to put here in this top box? Yes, we're going to put 16 ounces. You got that from the top. Good job. Okay, so if we have 16 ounces, then we have a part of it that Jim and Jane ate, right? So we could say, let's just say that this is the part that they ate. Okay, they ate this part here. This is a what? This is a 4th and 3/8, right? What do you see that you think you could do? Well, I think I could turn this 4th into an 1/8, don't you? 1/4, and what would it take for me to get an 1/8 here? Whoa, good job. You said multiply by 2. Good work. So what you do to the bottom, you must do to the top. So we have 2/8. So I'm going to change Jane's amount. I'm going to put 2/8 in its place. Now what does that mean? That means I can cut this up into what? That's right, I can cut it into 1/8. What goes in each box? If we have 8 boxes, what are we going to put in each one to make 16? 8 times what is 16? That's right, it's 2. So each one of these is 2, right? And those are 8ths. She ate 2/8, right? So she ate this much. And Jim ate 3/8. He had 1, 2, 3. So how many 8ths did they eat altogether? 5/8, right? You see we have 1, 2, 3, 4, 5. 1/8, 2/8, 3/8, 4/8, 5/8. How much did they eat total? 2, 4, 6, 8, 10. They ate 10 ounces. How much is left in the box? That's right, there is 6 ounces left. So they were asking, how much is left in the box? We're going to put this answer up here, 6 ounces. All right, well, we have another problem. Jack, Jill, and Bill each had 48-ounce bucket of water at the top of the hill. By the time they reached the bottom of the hill, Jack's bucket was 3/4 full. Jill's bucket was 2/3 full, and Bill's bucket was 1/6 full. How much water did they spill altogether on their way down the hill? So what's our number for everybody's bucket? Our number is 48. Okay, question. What am I going to break Jack's bucket up into? How many pieces? You're saying 4. Nice job. Jill's bucket is going to be broken into how many pieces? 3, right. And then Bill, who seemed to have the biggest problem, is going to have 6, right? I'm going to highlight that Jack's bucket was 3/4 full, right? So he had this all full. And then old Bill down here, he only had this much full. So how do we figure out what this is, what this box is? Because this is really what we're looking for, this box. And in Bill, all the boxes except for one. 48 goes in, we're going to ask ourselves, 4 times what is 48? 4 times 2, it makes an 8, right? And 4 times 1 makes 4. Would it be 12? Yes, it is. So Jack's bucket, he has what left? He's got 12. I mean, he spilled 12, right? Okay, Jill, we're going to look at hers. 48, that's what we have here. And she has how many boxes? 3. So 3 times what is going to be 48 for Jill? Well, if you don't know, you can always put the 48 inside the house and put the 3, and we can say 18, and we got 0. So how much is in each one of Jill's boxes? That's right, 16. Good work. You guys are getting the hang of this. I like it. So actually, it would be 16 on all of them, right? And it's okay if we want to fill these in. I think it's kind of helpful. Well, here's old Bill. Bill's probably the clumsiest of the bunch. It looks like he fell down the hill with his bucket. So we're going to say, what times what is going to be 48? What's our number that we're going to put here? Well, in Jill, we put 3. Why? Because she has 3 boxes. In Bill, we put 4 boxes. How many boxes does Bill have? 1, 2, 3, 4, 5, 6. So we're going to say 6 times what is 48. So 6 times 8 is 48. So what goes in each one of these boxes? Well, an 8, right? How much did he spill? Well, he spilled 1, 2, 3, 4, 5 8s. 5 times 8. So Bill spilled 40. So Jack spilled 12. We have it over here. Jill spilled 16. Let's put it over here. And Bill, he spilled 40. And then we add all these together because we want to find out how much water did they spill all together on their way down the hill. 6 plus 2 is 8. 4 plus 2 is 6. So the answer to our question is 68. I love math.